Hey, let's try number 11 in section 4.2. Like a lot of the ones in 4.2, we're going to find the max and min of this function, this continuous function, on the closed interval from -1 to 3. So again, on all of these, the way we do that is we want to check the value of this function at the endpoints and at any critical points. That then will be the list from which we will choose the maximum and minimum. So the max and min for a closed function, the max or min for a continuous function on a closed interval occurs at either the endpoints or those critical points. Okay. So let's take a look and see what are the critical points. We know the endpoints. What are the critical points? We need the derivative. Derivative of this function is pretty easy. I get the derivative of -5x squared is -10x. Derivative of 3x is 3. Derivative of -2 is 0. So real simple. The derivative is never undefined, but it is 0 when 10x is equal to 3, right? Then we'll get this to be 0. And so when x is 3/10, when x is 3/10 or 0.3. Okay, so we're going to check the original function, right? The original function at these endpoints, -1 and 3, and at this critical point 3/10. So if I plug in at -1, I get -10. If I plug in at 3, I get -38. And if I plug in at 3/10, we do want to give exact value. And you can use your calculator's convert to fraction button, but I've you could do the work here. If I plug in directly, of course, 3/10 squared is going to be 9/100ths. Multiply -5 times 9 gives me -45/100ths. 3 times 3/10, 3 times 3 is 9/10, minus 2. Put this all over a common denominator of 100. Multiply top and bottom by 10 here. I get 9/10 is 90/100ths. Of course, 2 would be 200/100ths. And then I have a common denominator. I can do -45 plus 90 minus 200 is -155. Over 100. That's the result. Common factor of 5. I can divide numerator and denominator by 5 to put the fraction in lowest terms. So there's our exact value, -31/20, which is about -1.55. Well, I'm sorry, not about. It is exactly equal to -1.55. Okay, so looking at our values again, we can choose from -10, -38, or -1.55, which is the smallest. -38, that's our min. Which one's the largest? -1.55 or -31/20, that's our max. And that is how we do this problem. Hopefully that makes sense. Again, all these problems very much the same in terms of the approach. Calculations and derivatives and etc. are of course differing in that, but we're always going to check the original function at the endpoints and at any critical points in that interval. Remember, between -1 and 3, 0.3 is between there. So only choose the critical points in that interval. Of course, we only had one critical point here, but if we had more than one, or even if the critical point we're given is not in this interval, we would not check it. So if there's no critical point between -1 and 3, you would not check it at all in that interval. But we always check the endpoints. Okay. Hope this helps with that. If you have questions about that, please let me know.